Alrighty, this is exam 3, question 6, A, B, and C. We're asked to use an algebraic technique to solve the given equation. First for A, x over x plus 3 over 2x minus 5. This is already in factor form, so we don't have to do anything else to this. We can go ahead and just apply this to 0. It all equals 0. So we can actually go ahead and do that right now. So set each of these to 0, so x plus 3 equals 0, and 2x minus 5 equals 0, as well as x equals 0. The principle behind this is that if you set any part of this equation to 0, the whole thing will equal 0. So we can solve for x using that principle. So minusing 3 here, we get x equals negative 3. Adding 5 here, we get 2x equals 5, divide by 2, and we get x equals 5 over 2. And we don't really care about this guy. As x equals 0 is x equals 0. And we can go ahead and plug this back into the equation if we'd like to check our answer. And we'll go ahead and do that for one of those, and we kind of see how we got. So we'll use x equals negative 3. So negative 3 times negative 3 plus 3 times 2 times negative 3 minus 5 should equal 0. So let's go ahead and distribute this out. That gives us positive 9 plus 9 times over here, which is negative 6 minus 5. This doesn't really matter as this equals 0. So 0 times whatever this will be will still equal 0. So that is indeed correct. We can follow the same principle with anything else. If you want to do 5 over 2, it would be the same thing. Like I said, as long as the answer you end up equals 0, your x values are correct. Alrighty, so we're going to go ahead and do B now, which is 9x squared equals 16. We can go ahead and actually move this 16 over to set up a difference of squares equation. Difference of squares will be a squared minus b squared. A squared in this case is our 9x and b is our negative 16. And this will become a minus b and a plus b. So we know that 9x squared is just 3 squared, right? Same thing with 16, which is just 4 squared. So knowing that, we can go ahead and break this equation down into two things. It's going to be 3x, because we're taking this into account as well, minus 4 over here, and 3x plus 4. Since we move this over, we're going to set this whole equation to 0, and we can go ahead and apply the last principle from the previous problem and solve for x. So let's go ahead and do that. 3x minus 4 equals 0, and 3x plus 4 equals 0. Plus 4, 3x equals 4 divided by 3. X equals 4 over 3. Excuse me, move a little fast. I'm out of room over here. 3x equals negative 4 divided by 3 as well. And then x equals negative 4/3. If we would like to, we can go ahead and plug that back into the equation. And why not? We'll go ahead and check using this x. And go ahead and see if the answer is correct. So 9 times 4 over 3 squared should equal 16. So 4 over 3 squared, when applying the exponent to both the numerator and denominator, is going to be 12 over 9. Multiplying that by each other, knowing these will cancel out, will give you, oh my bad, this should be 16, apologies. 4 squared is 16. Knowing this will give you 1, so 16 does indeed equal 16. And that's B for you. Important to note is the difference of squares formula that is used frequently through our factoring and a lot of this unit, so it's important to note. And we'll go ahead and do C now, which is the final one, which is 5x squared minus 4 equals x. We're going to follow a similar principle. We're going to move this x over minus the x, and we want to set this up in a way that we can use AC method. So you want our individual deciding power, so this is first, minus x minus 4, and add that 0 as we did for the last problems. Now we have AC method, which would be pretty straightforward. This will give us negative 20. And for negative 20 to add up to be negative 1, or negative x in this case, it would be 4 and negative 5. We're going to go ahead and slot that in the middle here. Right? We'll go minus 5x, just to keep it consistent, plus 4x, which equals this. This is now a polynomial, and we can, oh, sorry, my bad. And this is now a polynomial, and we can go ahead and factor by grouping to solve for x. So we can factor this one out by 5x, and we can take that out of both of these. We can't do 5x squared because there's no squared here. We can only take out 5x. So this would become just x. So we're only taking out 1x here. And then we're going to go ahead and add that minus 5. Oh, minus 1, my bad. Minus 1. And then we do the same here. We're going to factor out just 4 as there's no x here. Positive 4 to be exact. And this will go ahead and be x minus 1 as well. All equal 0. So putting this in an equation, we have 5x plus 4 equals 0, and x minus 1 equals 0. Same thing as last time. Move this over. X equals 1. 5x equals negative 4. X equals negative 4 over 5. And we can go ahead and plug this equation in. Why not? We'll do the fraction this time just to make things a little bit more interesting. So plugging this back into our original equation, 5 times negative 4 over 5 squared minus 4 should equal negative 4 over 5. So following the principle from the last problem, applying this power to both the numerator and denominator, we get 5 times negative 16 over 25. This cancels. This becomes 1. This becomes 5. We can simplify it early. This means become negative 16 over 5 minus 4. Okay, we need a common denominator here, so we'll just times this by 4. So it would actually be 16, negative 16 over 5 minus 20 over 5. And guess what that would give you? That would go ahead and give you, oh wait, oh, my apologies. I made a mistake. This should actually be positive 16 over 5 over 25, as this affects both the negative, so it's actually a positive. My apologies. But like I said, following the same principle still. It's a little late, so you have to forgive me. Like I said, it'll be 16 over 5, positive this time, minus 20 over 5, because we're making the denominator alike. And then this would give you negative 4 over 5. And that checks our answer. Sweet, that's all those problems. See ya.